All right, mathletes. So we're gonna go ahead and look at function notation and working with functions today. All right. So here's the idea. We're gonna choose some input. We'll call it X. All right. And what we're gonna see is we're gonna have this input and we're gonna apply these set of rules. Right. So the rules are gonna tell us what to do with these inputs. And then we're gonna examine the output, right? What it produces. And that's what we're going to be calling our Y values. All right, so we have our independent values, which is our X values. These are going to be either the numbers or the expressions or what's going inside of the function. And then the output is the dependent variable because that output depends on what it is that we plug in. All right, so let's actually do some math so we can see what I'm talking about. All right, so let's dive in here. Okay, so here we have this function y, and what we're used to coming from the land of y equals, right? But y and f of x, these are interchangeable, right? They mean the same thing, all right? So we have f of x equals 3x squared minus 2. So this is the rule. So it says you give me an input, and what I'm gonna do is I'm first gonna square that input. Whatever I get after I square it, I'm gonna multiply that by 3, and then whatever I get there, then I'm gonna subtract 2 from that quantity. All right, so this is what a function is. It's some set of rules, but what's nice about it is that for every one input, I'm gonna have exactly one output. So I'm not gonna put something in and have some options for output. No. Every time I plug in that same input, that output never changes. It's always gonna remain the same. So let's dive in here. So our first example, we have our function, we have our rules, and we said we're gonna plug in 3. So let's go ahead and plug in 3. So wherever I see my X value, all right, what I like to do is I tell my students, put a big old parentheses there because we're gonna plug something in. Well, what are we plugging in? Well, this notation tells us we're gonna plug in the value of 3. All right, now we just simply follow the order of operations. All right, so we go with 3 squared, so we get 9. So this turns out to be 9. Everything else you haven't touched, so we're just gonna drop it like it's hot. Bam. All right, go ahead and multiply those. So you get 27 minus 2. So we end up with 25. So notice our input, our X value was 3. And our output, right, what it produced 25. All right, so that's what we get when we plug in 3. Let's do another example as we're getting warmed up here. So now for part B here, notice we're gonna plug in -3. So wherever I see an X, I'm not gonna put that X there anymore. Wherever I see an X, I'm gonna put -3. So let's go ahead and do that. So we get equals 3 times, I put a big old parenthesis there because I know something's going in there. Well, what's going in there? Boom, what's in parentheses? That -3. So -3 squared. So -3 squared, we know that is +9. All right, and some of you are like, wait a minute, that's the same thing we got earlier. And you're right. Right, let's go ahead and we know how this story goes because it's exactly the same as what we saw earlier. So we're gonna get an output of 25. And this is where some people start to get confused. They're like, wait a minute, didn't you just say that whatever I plug in, I'm gonna get that same answer every time? Yes, and that's correct. So what that doesn't mean, right, it doesn't limit us to say that output could only result from that 3. No. It means every time I plug in a 3, I'm going to get a 25. Every time I plug in a -3, I'm going to get a 25. It's okay to get the same output, right? What's wrong is if I plugged in 3 one time and I got 25, and then later on I plugged in 3 again and got some different result, then this wouldn't be a function. All right, but by using this function notation, I don't have to worry about it. The author already tells us you're gonna get the same answer every time when you use that input. All right, let's do another example. So now we get some question marks, right? All over the place. Because what do I do? Now it's a plus 1. What the heck does that mean? Well, the rules never change in math. That's why I always spend time going into the breakdown, making sure you understand. Because if you don't understand, what you're going to do is you're just going to try to see what the teacher's doing and copying down everything the same. No, it's not about copying. It's about understanding. All right, so let's make sure we understand this. So wherever I see an X, I told you, put a space because we're going to plug in some input. In this case, the input happens to be this expression, a plus 1. So we got a little bit of work to do first, right? Because using our order of operations, we first need to go ahead and multiply that a plus 1. So we need to go ahead and distribute the a plus 1 because we got 2 of them. And you have to be very careful because the biggest mistake people make here is that they're going to square the a and they'll write a squared and they'll square the 1 and they'll write 1, which is completely different, right? Make sure you write 2 of them and FOIL this, right? Multiply everything out. You'll get a different answer. And try it off to the side and do it yourself just to make sure you understand. All right, so let's go ahead and distribute everything. And so once we distribute, notice what I'm going to do. I'm going to multiply the 3 last, right? So I'm going to distribute all this. So a times a squared, a times 1, I'll get a, another a times 1. So I end up with a total of 2 a's after I combine my like terms, and then plus 1. So after you FOIL this and you clean up the mess, this is what it simplifies to. All right, but again, on scratch paper, go ahead and multiply, FOIL that out, all right, just so you can make sure that this is correct. Now, I could go ahead and come through and multiply everything by 3. All right, so let's go ahead and do that. So we get 3a squared plus 6a plus 3, and then now I could drop down that minus 2. And we're always seeing, can I combine like terms? Can I simplify this? Well, there we have it. We can combine like terms right there. So in combining our like terms, we're left with 3a squared plus 6a. Combining all those like terms, we end up with plus 1. So this is our final result. Notice we didn't get a constant. We didn't get just one number as our answer. We got this expression. Well, look at what you started with. You started with an expression, and as a result, we ended up with an expression. Does that always happen? No, but right, don't be surprised when it does. All right, so let's continue the march here. So part D here, take a look. It says f of a plus 1 minus f of a. Notice, f of a plus 1, we just did that. So instead of doing all that work over again, right, use your answer. You already know what it is. And save yourself some time, because time equals money. All right, so let's go ahead, let's use this answer of 3a squared plus 6a plus 1, right? That was that. And let me do minus, let me do this next part in blue. F of a. Well, what's f of a? Well, that's just us going ahead. Wherever I see x, I know I'm gonna plug in a, right? So it's basically like f of x, except everywhere I see my value of x, I'm plugging in a. Well, why did I put parentheses here? Well, because we're gonna have to distribute that negative, because we're saying f of a, this, everything is gonna be the opposite, right? We're taking the opposite of that function. So we need to change both of the signs. So let's go ahead and do that. All right, so we're left with 3a squared plus 6a plus 1 minus 3a squared plus 2. Notice, after you distribute the negative sign, that changes both of these signs. Now let's go ahead and combine like terms. Notice you have a 3a squared and a 3a squared. Those will cancel. And then we have a 1 plus 2. All right, so we end up with 3. So we end up with 6a. That didn't have any like terms. plus 3. And that's all we could do right there, folks. All right, so once again, we're left with the expression as an answer. It's gonna happen. All right. Part E looks a little different here. It starts off with, okay, I'm plugging in -3, and then it has a plus 5. Again, follow your order of operations. All right, always stick to, what does this mean, f of -3? Well, that just tells us to plug in -3. And if we plugged in -3 last time, remember what our answer was, because we've actually done this already. When I plugged in -3 here, that gave me 9, right, times 3, which was 27, minus 2. So earlier, we already saw that f of -3 was positive 25. And so we already know that result. So first plug in the -3, and then we could drop down the plus 5. So we end up with the final answer of 30. So again, when you see this notation, make sure you first plug in your independent number here, your independent variable. In this case, it's a number, right? Evaluate this function, get an answer, and then go ahead and whatever this result was, then you go ahead and add 5. Same thing happens here. This looks very confusing at first glance as you're getting familiar with this, right? It looks confusing, but just use what you know. Well, what is f of 2? What does that actually mean? Well, it means wherever you see an x, we're gonna plug in 2 in that function, right? So let's start there. So sometimes what you gotta do is you have to take a step back and break these things up, right? Because if you try to just jump in there, it gets really overwhelming. So f of 2, right, wherever I see x in the original function, all I'm doing is I'm plugging in 2. Notice I'm ignoring all this extra busy work here. The only thing I'm focusing on, let me highlight it for you, is I'm just focusing on this. That's what all I'm focusing on right now. All right, so let's continue. So I end up with 3 times 4 minus 2. So I get 12 minus 2, which is 10. So f of 2, wherever I see f of 2 now, notice this takes on the value of 10. So let's just plug, wherever I see f of 2, I plug in 10. So let's do that now. So now we're left with 1/2 f of 2, which we now know is 10 minus 4. And let me go ahead and highlight it so we know where everything came from. Right, this was f of 2. So now we're left with 1/2 of 10 minus 4. Well, 1/2 of 10, that's just 5. So 5 minus 4 leaves us with the final answer of 1. So again, what you're gonna do is you gotta get your hands dirty. You gotta make a lot of little mistakes as you're processing this, right? As you're trying to understand what the heck is going on. So again, hopefully this video is helpful. If you want more practice, let us know in the comments. Don't forget to like, subscribe, and we'll see you in the next video. Peace.